Hey class, we're here, and now we're going to look at example 2 from chapter 8.5, and this is dealing with determining the actual dimensions from a scale model. So Esmeralda bought this toy tractor to give to her younger brother for his birthday. The dimensions of the toy are given in the diagram to the right, so pretend this is actually a diagram on the back of the box or something like that. The scale ratio on the package is 1 to 16, and she knows that her brother will want to know the size of the real tractor. How can she determine the dimensions of the real tractor? So one thing, I don't know if it's clear or not, but when you're dealing with similar figures, there's always a certain scale factor. So by the fact that those sides are in proportion, it means that there was a number that we multiplied all of them by in order to get the larger figure or the smaller figure. So in this case, we're giving a scale ratio on the package of 1 to 16. So I guess they don't actually come out and say it here, but it's logical that the tractor that they actually build is probably going to be larger than what this scale diagram shows. So if you think about what your scale factor is going to be, it's going to be 16 to 1 or just 16. So all of these measurements are literally going to be 16 times as big as what we're seeing here. So when we're trying to find the dimensions of the real tractor, we're simply going to take the height is going to be actually, and maybe I'll put a little subscript height r, is going to be 16 times the height that we see on our scale diagram. So it's going to be 16 times 12.7. So I'm just going to grab my calculator here, and we're going to do 16 times 12.7, and I get 203.2. And that's centimeters is my unit here. I haven't changed my unit. For the next calculation, maybe we'll do the width. So I'll say width of the real tractor is going to be 16 times the dimension we see there, which is 9.5. And so 16 9.5 is 152 centimeters. And then lastly, we'll look at the length of the real tractor. And we've got 16 times 19.1. And that comes out to be 305.6. And those are all in centimeters. If you wanted to convert them to meters, you could do that. It doesn't say anything about that on the actual problem. So literally, here's our dimensions of the actual tractor we would expect to get. So you can see this is not very hard. You're just determining the scale factor and then scaling up your model. The only difference between 2D and 3D is that you have an extra number and extra calculation.